In 1970, so we're all the way talking about 1970, a long time ago. In 1970, the Forest Service surveyed the Lake Tahoe Basin and determined that 60% of the land was in pristine condition. 20% of the land was in good condition. 15% of the land was in average condition. And 5% of the land was in poor condition. The Forest Service, was just surveyed or did just survey 200 randomly selected acres of land to see if the land conditions have changed. They want to know, has the land conditions changed? Is it still 60%, 20%, 15%, 5%, or is it something different, something else? All right. I box and emphasize this information because that's our claim here. We're trying to show or see if the land distribution has changed, if the land distribution is not the same as it was in 1970. And that's what we're going to fill into our alternative hypothesis. The land distribution is not the same. It's different. We're trying to see if the conditions have changed. Is not the same as it was in 1970. The null hypothesis is always the opposite of the alternative. So we're going to say the land distribution is the same. So just leave out that word not, as it was in 1970. For these goodness of fit tests, it's not very easy to write these symbolically. I know in chapter 9 and 10, we wrote all of our null and alternatives as a symbolic form piece, but it's not very easy to do that here. All right, so we're just going to write these sentences out, which was always an option for us before as well. All right, so we have our frequency, which, by the way, this is our observed frequency. This is the data that they just collected. They went out and they looked at 200 randomly selected acres, and these are what they saw as pristine, good, average, poor. The expected frequency is not from the collected data. The expected frequency is going to be from that 1970s data. All right, that 60% was pristine, 20% was good. So it's not that I'm writing in 60, 20, 15, and 5, because those are percentages. We need to know 60, if it was 60%, that's 60% of 200 acres, the 200 that we looked at. So we have to find what 60% of 200 is. Right, I'm looking up here, 60% was pristine. So 60% of those 200 should have been pristine if it was indeed the same as it was in 1970. This is equal to 120. Here we want 20% was in good condition. So 200 times 20%, which is 40. 20% of 200 is 40. All right, 200, we want 15% of 200 to be average. 15% of 200 is 30. And 5% of 200 was poor. 5% of 200 is 10. So you see the numbers are different from what was expected based on our 1970s data and what was collected now. The question is it different enough? Is the difference significant? And that's what our goodness of fit test is going to show us. We're going to be drawing those conclusions like we did in all of our other chapters. So we are going to use a LibreText statistics calculator for this. We're going to go to those calculators in our course, LibreText statistics calculator. We are going to go down until we see the goodness of fit. That's what we're selecting. Observed and expected. The order in which you enter these is very important because it is pairing and comparing the same data values. So here with our pristine, good, average, poor, we're going to put them in that order for both. So the observed is the values that we look at. That was 100, 45. This was the values currently collected, 35, and 20. The expected is the values that were based on the 1970s percentages. So expected would have been 120, 40, 30, and 10. We click calculate, and this is going to give us our test statistic. That's that chi-squared piece right there. That's what that weird looking X is, by the way. That is chi, the Greek letter. All right, so that's our chi-square. The p-value is the same as the p-value that we have been using this whole time, and we are going to compare it to alpha. We are going to run a distribution here, run a hypothesis test, sorry. All right, so let's write those down. Hopefully you are taking notes on these calculators. I recommend you kind of write in your notes exactly what you see when we go and type in that. So when you do your homework later, you can see. So chi-square was 14.792. Think your online homework typically as you round to 3 places for the test statistic. And then this is the test statistic. The p-value, they usually have you go 4 places, 0.0020. So you could leave off that last 0 if you wanted. All right, degrees of freedom. So 1 less than the number of categories. In this case, there were 4 categories. So it's 1 less than the 4 categories that we had, right? 1, 2, 3, 4 categories, 1 less than that. So the degrees of freedom is 3. I added the let's use a 5% level of significance here, but anytime you're not given a level of significance, we need that to make our decision. So if you're ever not given a level of significance, we use a 5% alpha, a 0.05 for alpha, 5% level of significance. It's just our standard amount. If it's ever not given, that's the one that we retroactively go back to. All right, so we are comparing that alpha of 0.05 with our p-value, 0.002, 0.05. And we have that alpha is bigger or p is smaller. Remember, if the p is low, that means the null must go. So our decision is to reject H naught, reject the null hypothesis. If I ask on an assessment or something, what's your decision? This is what I want to see. And I don't want to just see reject or fail to reject. I want to see reject H naught or reject the null hypothesis. It's important that you're not just saying reject or fail to reject, because if you were telling someone else that, or even telling me that, maybe you think you're rejecting the alternative. Maybe you don't even know what you're rejecting. What we are rejecting is this guy right here. And if we reject him, that means that this guy, the alternative, is good to go. All right, that's what this is saying, and that's what our conclusion will then support. For our conclusion, we always want to include the level of significance at the 5% level of significance. We always want to say if we have the support or we don't. In this case, we did have the support, so there is sufficient evidence to support. And here is where we put in our alternative hypothesis. That alternative hypothesis. So to support that the land distribution is not the same as it was in 1970. I'm just going up and pulling that alternative hypothesis and pretty much putting it in. Now that we have it in words already, we don't have to worry about translating from the symbolic form. So to support that the land distribution is not the same as it was in 1970. All right, let's go try another one.